Henrik Melser is our first presenter, and I believe he's here, and he'll make his way up to the podium. Henrik is the Northwest Regional Process Manager for Brown and Caldwell. He has been responsible for the integrity of all process designs for both industrial and municipal treatment plants created in Brown and Caldwell's Northwest offices for the past 20 years. He was last year's winner of the WEF's Camp Medal that is awarded to individuals that have successfully demonstrated the application of new and innovative technology in full-scale wastewater treatment plants. Please join me in welcoming Henrik Melser. This is...
Good morning, everyone. I'm pleased to be a part of the panel and kick off the proceedings and dive deep into wastewater. Can you hear me? Good. So what I wanted to talk a little bit about was what opportunities exist in wastewater treatment. And I thought it might be useful to consider where we've come from. It turns out that next week is the 40th anniversary of the Clean Water Act. And I don't know if any of you were around at the time. I was just beginning my career at that time. And there were pretty bold sort of pictures in the newspapers. There's one on the right shown of the Cuyahoga River in Cleveland being set on fire. And some of you may remember the disaster at Love Canal in Niagara, New York. And Rachel Carson's epic book, Silent Spring, in which she opened people's eyes as to the problem associated with the widespread use of pesticides and other chemicals. And so it's interesting, I think, just to quickly look back and where have we come from. And over the last 40 years, I think it's pretty clear if you look at many wastewater treatment plants, as a community we spent billions and billions of dollars in upgrading treatment plants to introduce what we call secondary treatment. Secondary treatment involves a biological treatment step where we remove a lot of dissolved species like organics and nutrients. And as part of that program, there was something called the Advanced Wastewater Treatment Program, in which EPA essentially underwrote the introduction of many, many new technologies. And for its time, and even today, I thought it was a very good program because it took the heat off municipalities in terms of wondering if their investment was going to pay off. Because by underwriting these, essentially EPA took the risk away from the municipalities. So people, companies were allowed to introduce new technologies. And despite the fact that there were a lot of successes, there were also some very notable failures. And EPA did step up to the plate. They paid for removing the full-scale installations and replacing it with more conventional technology. And I think it's sad that we've moved away from that concept today, because if we are to further advance systems, I think it would be good for the federal government to share in the risk of doing something like that and advance our systems even further. One of the interesting things also at the time was the EPA, I thought, had some vision by introducing pre-treatment programs. Rather than focusing on end-of-pipe treatment, in other words, deal with everything once it gets to the sewage treatment plant or the industrial treatment plants, what they said was, we are going to introduce a set of rules whereby we'll limit what goes into the sewage treatment plant and force the dischargers to introduce a different level of technology which would minimize the impact of what they discharge. And this is particularly aimed at industry. such that they don't prejudice the proper operation of the sewage treatment plants. And the example I have is I was deeply involved at that time working for a high-risk research lab for Environment Canada in the Toronto area. And our charge was to develop methodologies and modeling approaches to investigate the fate of volatile organic contaminants, which were a subset of toxic chemical emissions. And at the time, we measured concentrations in the influence to treatment plants at the level of 1 milligram per liter or greater. Doesn't sound very much, but it was extremely significant in terms of the impact on receiving streams. And over 10 years after the pretreatment program had wound its way, we made measurements again, and that level had dropped by 3 orders of magnitude, where we were measuring numbers in the range of 1 to 20 micrograms per liter. And I think it's good that we have a multi-level approach to solving some of our wastewater pollution control problems. I'd like to also speak about some of the major advancements in the science and engineering of wastewater treatment. I'm not trying to bamboozle you with a lot of acronyms here. Rather, it's shorthand for explaining that there are many, many, many new technologies in the marketplace. And BNR stands for biological nutrient removal, membrane bioreactors, moving bed biofilm reactors, combined heat and power systems, and new technologies that look at energy conservation and high-rate anaerobic treatment. These have all advanced our ability to treat a wide range of different waters and ratchet down the concentration of residuals to meet the more and more stringent regulations that the authorities are challenging us with. We have a number of examples of these new technologies, both within the city of Tacoma, also Pierce County and the surrounding South Puget Sound area. There's a lot of new concepts that have been developed where we're looking at what have we got, how do we make best use of it. By that I mean asset management, the capacity assessment of treatment plants, BCEs, business case evaluations. These are all becoming pretty standard tools in terms of developing the most cost-effective methods for implementing wastewater treatment technology. One of the nice things that have come along with the advancements of computer technology is that we can simulate a lot of what goes on in wastewater treatment plants in a dynamic manner, in other words, in real time. So I can track what happens as a function of the material that's coming in the door every minute, every hour, every day of the year. And that's an extremely powerful tool for us to be able to comply with regulations that call for daily maximum effluent requirements or weekly maxima. Very hard to ensure that we meet those targets when we have so little control over what's coming in through the pipe. And over the years, we've seen new challenges have emerged, CECs, chemicals of emerging concern, resource and energy recovery. The previous speaker spoke briefly about that. We don't look at wastewater any longer as something to treat. There are things that we can extract from it: heat, power, nutrients, clean water. These are all ways of looking at wastewater as a resource as distinct from an end-of-pipe treatment chore. There are other things that are being forced upon us by EPA, the need to treat storm-driven high flows that enter sewage treatment plants, combined sewer overflows, storm sewer overflows, and water use, reuse issues, which I'll speak about shortly. So what are the new challenges facing us? Nutrient removal, wet weather treatment, escalating water demands, minimizing energy and carbon footprints. I'm sure you've read the press and the local newspapers. These are all things which are prominent in our day-to-day existence. What sort of things are we doing? What can we do in order to capitalize on the opportunities that exist with these new challenges as a community? What new industries can we grow that respond to these new challenges? One of the interesting things with respect to minimizing energy and carbon footprints, it's coming more and more to the fore that water and energy are really interrelated to a very great extent. We need energy to drive the pumps that bring the sewage to the treatment plant. We need energy to pump the materials through the treatment plant. Yet we can extract energy from the wastewater through biological processes that generate methane, which can be captured and to power boiler systems to create the power to be able to close the energy loop in the system. There is heat capacity in the sewage. It is now feasible, and there are full-scale plants, not necessarily in this country, but certainly in Europe, in which the energy cycle is being completely closed. In other words, that those treatment plants do not need any external source of power in order to be able to drive them. And there has not been an incentive in this country for us to go that way because our energy costs are so incredibly low compared to other communities across the globe. So while the incentive is beginning to appear in places like the Northeast Corridor of Southern California, it's kind of contrary here. We are the recipients of very cheap power in the Columbia River area. We have huge hydroelectric dams. I'll give you an example. One community in eastern Washington, I was asked to install something we call fine pore diffusers. These are very efficient methods that we use for transferring oxygen into solution and to introduce high-speed new blowers. I had a very hard time trying to make the arithmetic work to justify the expenditure because the return on that investment was not substantiated on the basis of the cost of the power we were buying in that area. So there's a dilemma. While everybody recognizes these are excellent things to pursue, we have to be aware of the marketplace-driven constraints, which in this case happen to be energy costs. So locally here, I show Pierce County, obviously Tacoma, in the state of Washington. Nutrient control is a huge initiative that EPA is trying to apply nationwide. And showing a picture of the state is just to illustrate the fact that the challenges from a wastewater treatment perspective are dictated by geography. Everything to the left or to the west of the Cascades is driven by nitrogen control requirements because most treatment plants discharge into a marine environment, and the constraint with respect to nutrient-driven eutrophication is nitrogen. If you go on the eastern side of the Cascades, all the discharges are into fresh water. In that case, the limiting nutrient is phosphorus. So the technologies we apply are very, very different depending upon which side of the state you live in. So that drives the innovation, it drives the application of different types of technology. And so if you're trying to grow new industries in this area, you need to understand some of the market forces which are generated by the geographical and water receiving constraints that exist in our state. Point source versus non-source. Non-point source. One of the failings of the Clean Water Act, I think, was the fact that they didn't tackle the issue of non-point source discharges. And we're spending billions and billions of dollars today on ratcheting down smaller and smaller concentrations of residuals to be discharged to the receiving waters. Now, in principle, that's a good thing. But when you compare that with the tons, thousands of tons of organics and nutrients which are running off farmland, these are what we call non-point source discharges. There's very little constraint on that. And one wonders sometimes if you apply the same level of investment that we're applying to point source discharges to the non-point source discharges, whether the environmental benefit would be greater than what we're seeing right now. And I think that's a philosophical question that you should be examining in terms of creating the opportunity for startup businesses. Certainly there's a huge challenge out there with respect to garnering control of non-point sources in our state and across the United States in general. Conscious of time here, I'm going to brief. 2 minutes. Okay, I was going to give a couple of examples of things that are pretty big on the horizon. One is side stream treatment technologies. These are used to offset the cost of introducing nutrient removal in wastewater treatment plants. These are very, very expensive to achieve. What we have was when we digest sludge, we produce a liquor which is very rich in nitrogen and in phosphorus. And you see here these are small flows, 1% of the total plant flow, but extremely high concentrations of the both nutrients. And so we've developed technologies that are existing in the marketplace that since you can focus a specific technology to a small portion of the flow that carries as much as a quarter to a third of the total nutrient load at a treatment plant, you can reduce costs enormously. And I'll give an example of Pierce County at the Chambers Creek plant expansion. We demonstrated something called a Demon technology, which is a European invention that addresses removal of nitrogen from these dewatering streams. We showed the county that by installing that technology, we would shave $7 million from their total plant capital cost investment out of a total of $260 million, which is a significant saving. Plus, there were hundreds of thousands of dollars a year in operating costs because we eliminated the need for about 60% of the aeration and the methanol required for denitrifying those streams. A few technical terms, but bottom line is there are a wide range of these technologies in the marketplace that you might want to examine as opportunities to develop locally. And the last example I had were ballasted systems. And here you see the use of either sand particles or magnetic materials such as ferric oxide. These can be used in circumstances which call for settling of particles. You can garner a lot of biological and organic particles so to escalate the rate at which you can settle them. And so when you add these ballasts, you can create a ballasted system. And so for wet weather treatment, that is storm-induced high flows through treatment plants, there's a number of options. Actiflow, it's being used locally in the city. Bremerton, Denzadag, and BioActiflow and Biomag are biological supplementations of the same technology. They compare with non-ballasted systems, which has been implemented, say, locally at Brightwater, and I show 3 different types of competing technologies. These are all excellent technologies. They have their advantages and disadvantages, but again, we live in a part of the world where it rains a lot. Every treatment plant has to face this problem, so there are opportunities for implementing these types of technologies. And the last one, ballasted systems can also be used for phosphorus removal whether or not you choose to apply Actiflow or Comag. The alternatives can be and has been demonstrated at Spokane in the massive pilot demonstration facility they have there. You can do it either way, with or without ballasted applications. And with that, I'll close my presentation, and we'll just invite the next person up.
Thank you, Henrik, very much. Dan Thompson will be our next speaker. Dan is the manager of wastewater operations for the City of Tacoma Public Works Department, Environmental Services Division. He has over 30 years experience in the environmental field, including 18 years in water, wastewater, and biosolids management. So please join me in welcoming Dan Thompson.
This is good. You'll probably notice the similarity in title between mine and Henrik's
I'm glad this got loaded. I
today.
Told Jim that.
That's totally by accident, but probably predictable. Because what we're really looking at here is opportunities here to harness the infrastructure that we've already built, not only in gray infrastructure, green infrastructure, but also in human intellect that we've amassed to kind of operate these sorts of things. I thought it was interesting in Mr. Brown's presentation earlier today that he talked kind of on the 100,000-foot level about vision. Because I want to talk about vision, but I want to talk about it on the micro level. And so what I'm going to do is I'm going to introduce you to the weeds and invite you down in. So the first thing I want to talk a little bit about is what are the opportunities that we have out here with regard to the specific infrastructure that Tacoma has to offer. We look at ourselves as a manufacturing plant. Henrik kind of touched on this a little bit. In the past, we've kind of looked at wastewater treatment as a means to purifying water that we would then discharge and not think too much about. We don't look at it that way anymore. I think a better analogy to what we do anymore is to look at a smelter. We take in a raw product, and we do a lot of different things to it, and we extract a lot of different things out of it. And I think that's where the opportunity lies, particularly in this context that we're talking about today. We manufacture clean water. That's the first thing everybody thinks about with a wastewater treatment plant. There's a lot of things we can do with clean water. We also manufacture grit, which is something not many people think about at all. But we've actually had a fair amount of success in recycling grit, although that's kind of crashed lately. We also get fats, oils, and grease, better known as fog, not what you see out there today, but much more disgusting and smelly. But it also has a lot of properties that are useful. We manufacture biosolids, and here in Tacoma we have kind of a flagship program where we've had a lot of success in recycling biosolids and making a value-added product that people are actually willing to pay money for. And finally, we also can, as Henrik touched on, get energy out of this product as well in a lot of different ways, not just from heat, but also in physical properties as well. So there are services that we can provide through a wastewater treatment plant that are kind of non-traditional. The first thing that you think of when you think of a wastewater treatment plant is you hook up to the system and you discharge to it, and we take away whatever it is you don't want. But we also have other ways of doing this, and one of the things we're working at today is treating other people's waste directly at the treatment plant, having it trucked in. So particularly down in California, but also here in Tacoma, we can take trucked in waste directly into our digesters, process that material, get energy and soil amendment products out of it, but also charge a fee for what we're doing. There's another economic opportunity there. I want to talk a little bit about water reuse. That's kind of difficult in the rainforest, as you might imagine. We kind of touched on that. Water has a lot of value, but when you have a lot of water and it's relatively easy to get it to the people that need it, it's hard to make things pencil out to do water reuse. There are a lot of different things you can do in water reuse. Some of the things, typically what you think about is irrigation or things of that nature. There are other uses for water that I think we need to think about if we're going to be successful in doing water reuse in the Pacific Northwest. I touched a little bit on grit. We used to have a grit composting program here in Tacoma in which we would actually take the grit. For those of you who don't know what grit is, it's the heavier solids that come out of the front end of the treatment plant. It consists mostly of sand and then some organic matter on top of that that's kind of disgusting and smelly. But it is compostable, and it does have a lot of energy, and actually makes an excellent soil amendment if you can do it. And the problem is there are some certain health aspects to that because it's a relatively raw product. So you're looking at my electronic leash is really tugging at me today. I turn that damn thing off. There we go. But you have to take care of the health issues first, get rid of the pathogens and that sort of thing. So there's an opportunity there. Fog is kind of an interesting beast. There's a lot of different things you can do with it. There's a lot of energy in fog. And so one of the first things that a lot of plants do with fog is feed it to their digesters, and they create biogas out of that. And then you can either run electrical generators or just fuel boilers or that sort of thing. Fog can also be made into biofuels. And in fact, we had a pilot that we did briefly here in Tacoma where we took a little bit of fog and tried to make biodiesel out of it. The pre-processing was really an exercise in how strong your stomach is, because that's a very difficult product to work with, and it's very difficult. There's a lot of free fatty acids and a lot of really smelly stuff, so when you're trying to process it out into actually making something into it, it's a problem. This is where the opportunities lie, though, is because we don't really have good technology for that now. Doesn't mean we can't develop it. And I think a lot of what we're talking about here today is not the technology that we have today, but the start of something that we could do tomorrow. And I think there's a lot of opportunity here. We talked a little bit about energy. Right now, we're like most wastewater treatment plants in the U.S., we have anaerobic digesters, and from that we produce biogas. I think, I'm going to pause for a minute. One of the interesting stories about Tacoma in general has been our willingness, I think, as a city and certainly as a utility, to try different things even though they don't always work. And I think our experience with biogas is one of those. We have boilers, that's easy. I mean, you fire off biogas, you heat a boiler. We actually heat our entire treatment plant off of biogas. That's a good thing. But we tried to go one step further, and we created something called the Gas Utilization Facility. And we were using that to take the biogas, strip out the CO2, more or less purify it, and compress it into compressed natural gas and run our trucks off it. At the time that we did that, the technology really wasn't good enough, particularly in the standpoint of the CNG types of trucks that we were trying to run. And the process didn't work too well, and we've since abandoned that. We're probably going to try to run up that hill again here pretty soon. But these are the opportunities that are going to present themselves in the future. We've already been presented as far as I know. But so there's a real opportunity as we get better at different things to retry some of this stuff we've tried in the past. We have, I think, a basis for looking at all these bigger things that come out of a wastewater treatment plant, but we're getting better at processing these things and making them pencil out. Henrik kind of touched on that. A lot of the stuff that we talk about, it's not that we can't do it, it's that we can't do it very efficiently right now. And so that's where the opportunities are going to lie. Biosolids has been a real success story here in Tacoma, and we've been doing this since 1953, recycling all of the biosolids that have come out of our plant. As time has gone on, we've gotten a little more sophisticated by how we do this. Originally, we just took primary sludge, digested it, and then put it on the back gate and waited for farmers to come and take it away. Pretty simple program. We've gotten a lot more sophisticated. We now make for one thing, we have a secondary plant, so we have much more biosolids than we used to have. But we also make a value-added product where we add various other things like sand and sawdust and bark, and we make products that, A, don't stink, which is really important because nobody likes to pay money for that kind of stuff, and two, are very effective in home gardens and also on turf fields and other things like that. And we've had some real success stories on local soccer fields out here. We've actually been used out at Cheney Stadium. We're very effective in the home garden market right now. And also, if you go down the street a little bit, one of our more innovative products was a green roof soil medium, which is over on the South Park building. We've done some rain gardens, although that's another one of those things where we got to get better at that in order to be really effective. So there's a lot of opportunity here, and there's a lot of work that still needs to be done. One of the big things for us is to make a product that actually is good enough to be used inside your house. And so we have a new bagged product now, which is basically odor-free, that we sell out of, I think we have 11 retail distribution outlets right now. And I think there's a lot of room for specialty products here as well. We've only begun to really scratch the surface on this, and I think as we get more people thinking about how to do these things and how to do them better, there's a lot of opportunity. The other thing that we're doing is external waste treatment, where we're taking in trucked-in wastes. We started this by taking in just sludge from other treatment plants, Gig Harbor and Yelm, and we've since moved on to at least looking at the possibility of taking in food wastes and other wastes directly into our digesters. There's two advantages to this. One is we don't use the front end of the treatment plant, which is about half the cost of doing treatment, so we save a lot of money there. The other is it gives an alternative to some of these waste treatment or people with waste treatment problems, other than either hooking up to the sewer and running it all the way through our system or sending it to a solid waste facility or something of that nature. So there's possibilities there. There are a lot of roadblocks there, and we're kind of looking at those, particularly in the food waste, is how do you get the food waste there? What's the best way to get there? How do you prep it? So there's a lot of opportunity and a lot of thought that needs to go into that before we will be ready to really take off and run with that. I talked a little bit about threats, and I put this out here, and I want to use the poster child threat, which is nitrogen limits, and Henrik touched on this a little bit. But what I'm really trying to get at here is nitrogen is what's facing us. As Henrik mentioned, we're on the west side of the Cascades, and this is going to be the thing that's going to come up and be the big dollar ticket item for our wastewater treatment plant, most likely. And the problem with that is not so much that it's a bad thing to limit nitrogen out of treatment plants, it's that it's an ineffective thing and it's an expensive thing. And so the question is how do we create an infrastructure? How do we take a kind of a group approach to this and a more global approach to this to where we get the biggest bang for the buck? And the problem we have right now is that under the Clean Water Act, we have no authority over land use. So if we can't do land use regulation and we can't keep people from doing land use practices that have more detrimental effect to the health of Puget Sound than, say, a few extra milligrams per liter of nitrogen. So we waste a lot of money, and we've recently completed a study, and King County up north has recently completed a study on what it would cost to put in nitrogen removal down to 3 milligrams per liter. And the cost is staggering. For us, it's somewhere closing in on $1 billion, that's with a B, $1 billion. For King County, it's over $2 billion. What could we do with that money if we had the opportunity? What would be the best way, really, if we wanted to protect the Sound, to use $3 billion? And then how do we create a structure in which we can use that money in different ways rather than just trying to slavishly comply with the Clean Water Act? So those are the challenges that I see in front of us. And at that time, I'll yield to whoever's number 3 on the list.
Randy is Deputy Director of Public Works at Joint Base Lewis-McChord. In 1982, he left his military career as an Army aviator and field artillery officer to pursue an engineering career in the U.S. Civil Service. He's got a master's degree in environmental engineering, and in his current position, and this always amazes me when you get into the details of what goes on at Joint Base Lewis-McChord. He's responsible for all aspects of maintenance, repair, and construction on the military complex, which is, by the way, the largest west of the Mississippi, and with a team of more than 400 engineers that work with him, scientists, planners, and craft workers. He's responsible for ensuring the maintenance and operations of the 86,000-acre installation with a daily service population of over 100,000 people. So with that, please welcome Randy Hanna.
Thank you very much. So it's an honor to be here today, and I look forward to participating this afternoon. But before I get started, I need a real quick survey to help guide me with my remarks. How many people in this room know where Joint Base Lewis-McChord is? Good. How many people in this room cuss Joint Base Lewis-McChord when you drive south on I-5? Okay, now we're over that. How many of you know what goes on behind that fence? Okay. How many of you, if I put this in front of you, would drink this water? It's on the other side. Okay? So nobody would drink this water? Okay. How many of you would drink this water if I told you it came from a wastewater treatment plant? Therein lies the problem. Okay. So what's up with Fort Lewis? We call it used to be Fort Lewis and McChord Air Force Base. Now it's called Joint Base Lewis-McChord. 2 years ago, under the BRAC authorization and mandates, we became one. Lots of reasons for that, which I won't go into. But we are, if you combine both the installations, we're about 92,000 acres. Our economic impact to the area is annually about a little over $6 billion a year. We have an annual daily service population of about 100 to 125,000 people per day. And on top of that, you can add about 22 to 25,000 retirees in the Puget Sound area that visit Joint Base Lewis-McChord for a variety of reasons, whether that is commissary or medical privileges. We have about, depending upon the year, we have anywhere from $100 to $350 million worth of construction going on at Fort Lewis, Joint Base Lewis-McChord at any one time. You have to forgive me, I flip back and forth between Lewis and JBLM because I'm an old-time hardliner. Anyway, of course, now the construction that we're talking about will ebb and flow as Congress ebbs and flows funding to us. But one of the unique things that is happening here at Joint Base Lewis-McChord, we're being recorded, so I have to be very careful about this. We're undertaking the construction of a new wastewater treatment plant. And you know, it's not enough just to build a wastewater treatment plant anymore with current standards. You've got to anticipate your future regulatory environment, and you've got to build to that. And in view of Joint Base Lewis-McChord, we're not stopping there. We're actually going to attempt to build this plant with an eye on the future. And for us, the future is what we call net zero. In April of 11, the Department of Army nominated, or I'm not sure it was the nomination or it was one of these phone calls that goes, hey, by the way, you are this now, figure it out. I think that's kind of how it happened. They made the phone call, and the next thing we know is we are being held up and announced as one of 17 worldwide installations for net zero for water and wastewater and waste. Now, basically, that means, here we go with these lofty goals and these visions that come with it. By 2020, I have to have zero waste. Okay, think about that. By 2020, I have to have zero wastewater discharge with full water reuse. It's already 13. My physical year started 1 October as FY13. 1 January, I'm already starting an annual work plan for 14. The race is on. 7 years, 6 years, holy smokes. So far, we've already diverted 68% of our solid waste to avoid landfill. By 2020, our goal is to have nothing going to the landfill. That last 32% is going to be a bear, okay? With the construction of our new wastewater treatment plant, not only are we going to put a cleaner product back into the Sound, we're going to put Class A drinking water standard discharge back into the Puget Sound, phase 1. Phase 2 takes that and diverts it from Puget Sound into a comprehensive water redistribution system. Now, I don't know if I'm going to sell this yet or not from our wastewater treatment plant, but we will have a lot of opportunities for reuse throughout the sprawling metropolis of Joint Base Lewis-McChord, whether it's infiltration galleries, whether it's water features, all of those things come into play. You've heard today that we're in a water-rich environment. Well, I want to take you back to the early 90s when for 2 years our snowpack in the mountains was so depleted that we were scrambling for water here. First time we ever thought about water rationing, first time we ever thought about water conservation seriously Can it happen again? Probably. Will it? Sure. You know, I'm not here to talk about global warming, but all you have to do is look around, and it wouldn't take much of a climatic change for us to be in that box again. So think about that a little bit. A lot of these programs that I'm talking about, as Henrik mentioned, don't necessarily pencil out. But from a taxpayer, I expect my government to be a leader in technology and environmental compliance and environmental stewardship. And that's why one of the things that we do at Fort Lewis is known as our sustainability program, and that's integrated into our net zero program. Every project that we undertake, whether it's a multi-million-dollar construction project or a repair and maintenance project, undergoes a fairly significant scrutiny for sustainability incorporation. Whether it's photovoltaic cells on roofs or whether it is just a selection of green materials in our construction projects, all of it plays to the bigger conservation and sustainability role that I think we're all responsible for and that we all have to commit to. I'll let him get his picture. Thank you. And they got a job to do. So, where does this come? How does this relate to us in the room today? Well, I talked about the 32% are going to be hard to get. I talked about the technology about water reuse is going to be hard to get, and that's kind of why I'm here. We need industry's help to help us get to those lofty net zero 2020 goals. You know, when you're on the bleeding edge of when you're on the cutting edge of technology, you bleed a lot. Well, we're tired of bleeding, and we really, really, really would like to see Tacoma come to the level of expertise and bring in some new technologies, some new community action plans, and some new industrial solutions that not only we can use at Joint Base Lewis-McChord, but you can propel throughout the region and into the nation, because these are solution sets that all communities are wrestling with, be it big or small. It's just something we have to get our arms around. So I think, I've always been told that the best speaker is the speaker who keeps people on schedule right before lunch break. So I think I'm going to bow to that and get us back on schedule. Thanks.
So anybody want to start us off right here in front?
First of all,
identify yourself, please.
Oh, hi, my name is Jim Parvey. I'm with the city of Tacoma, and I would just say, hey, you guys, awesome presentations. That was amazing. The one thing I noticed, you all talked about, the costs of implementing these new technologies or these new processes. And I often wonder if the question is always, what's the cheapest gallon of water we're going to buy or the cheapest kilowatt we're going to buy? It doesn't really allow for much innovation, just partially because of our geographic location. And so don't you think a better way to talk about the cost is to look at all the costs? It's not just the cost of buying the water, but it's the cost of disposing the water. It's not just the electricity, it's the impacts of generating that electricity that might be played out other ways. And so I'd just be interested in hearing any one of your thoughts on that.
Who wants to start out answering that? Any one of you?
Okay, are we on here?
Yes, you are on. And by the way, the mics are important, and thanks, Jim, for being a good role model, because that's what picks it up on the video. So if we speak without the mics, we don't pick up the voices. So go ahead.
So we do use a triple bottom line approach, right? So, and that gets us part of the way there. But the other thing is that not every technology works everywhere. So I think it's important for us here in our region to look first at the things that work here. And maybe that's where the innovation has to come, is because maybe we're going to do things differently here than they are in South Florida. And so I think that's how we kind of approach it here. We, as a public utility, certainly we can't be going around just doing things because they're really cool.
One of the things, if I may add, one of the things that we struggle with is trying to assign value to sustainability. Okay.
That one wasn't on.
Trying to establish value on sustainability and environmental compliance. Clearly you can put a dollar on non-compliance, but when it comes to putting a dollar value on leadership, stewardship, sustainability, that is difficult to do. And so that is one more element that you have to add on top of the triple bottom line. And that is probably the most difficult to get a hold of. If you're in front of a passionate crowd, it's easy to sell, but when you take it back to the banker, tough to get your arms around it.
Excuse me, I'd just like to add that from an engineering perspective, we work for you, the clients, and one of the biggest drivers is always how can we keep the cost low? And so if you're starting a business, then you have a high element of risk associated with it. And someone has to underwrite that risk. And remember I spoke a little bit about in the early days of the Clean Water Act, EPA's Advanced Wastewater Treatment Program. They provided that assurance that they would bail out people in the event of a total failure. I'm not advocating that you should do it here, but I think there has to be a recognition that risk has cost associated with it, and somehow that has to be part of that equation.
Thank you. I think we have a question in the back. Go ahead and identify yourself.
Hi, I'm Jim Kramer. I'm a consultant working with the Russell Family Foundation. Paul said that one of the things we need to have is a vision, and Bruce gave it to us earlier, being the Hollywood or the Silicon Valley for water in the world. So I'm wondering, in terms of now, what do we do in the Tacoma area that draws people from other parts of the country or world to see how we're doing it? And what would we need to do in terms of issues, in terms of wastewater, that would draw more people to come see what we're doing here?
Sounds like that's for all of you, so whoever wants to.
So I think the first thing we need to do is create a community vision. You know, that's kind of what Paul was really saying. And that's going to require an integration of thought, certainly between all the utilities, and I invite my friends from Tacoma Water to participate heavily in that, and also at Power. In order, that's just a starting point. And then at that point, there has to be a willingness to take some risk. There has to be a commitment to the vision. And then I think we do also have to open this up to be fairly transparent so people can kind of see what we're doing.
I'd add to that is the element of education. It never ceases to amaze me how a lot of the members of the public just take for granted what comes out of the tap, of how much infrastructure is below the ground that's decaying away and has been decaying away for 100 years or so, that they have no appreciation of what happens when they flush the toilet. They just pay their rates and forget about it. So if you're then trying to generate a community vision, I think one of the things that you have to do is to educate them. Whether you do that public fora or start at the bottom at the school level and wait for the generations to come through with that knowledge base, different timelines. But nevertheless, I think you have to reach out to people and generate the enthusiasm to support ventures that would be risky in some ways, that would open the doors to venture capitalism, that would open the doors to people from overseas looking at what it is that you're doing that you could sell to and so on. But I think there's an important element that you have to get the community behind you, and if they don't understand what it is that you're trying to do, then it's not going to be very successful. I'd speak to the concept that was promoted earlier on in Singapore, theirs is a matter of life or death, where they're a little island, it rains a lot, but they're surrounded by seawater, and they have one of the most densest populations in the world. Everybody gets it there because they don't see anywhere else to get their water from. So it's a lot easier, I think, well, partly also because the form of government they have too. But by the same token, I think people get it over there because they need it to survive. We have so much water here that we take it for granted. So you need to turn that concept around a little bit and say, okay, what can we do with the resources we have here? What are our strengths, as Dan mentioned, our intellectual knowledge through the people that live in this area, their knowledge base? How do we bring them to the table and make use of them?
Just to follow up on what Dan said, there are a number of alliances or singularly focused organizations in the Puget Sound area that are dealing with or addressing water conservation or water pollution in a variety of ways. And I think you hit it on the head. If you could bring all of those together, you would get a very, very powerful alliance or group of organizations that would be a force multiplier, so to speak.
Another question in the back, thank you. Please identify yourself.
My name is Ben Ferguson. I'm with BLRB Architects. The keynote speaker, Paul, was speaking about the need to decentralize and to kind of spread it out. And all three of these presentations were about something at a civic scale, which it's important that we're pushing forward in that area. But I'm wondering if, as an economic development conference, if we shouldn't spur businesses to come up with ideas for centralized but also decentralized. If there's a lot more consumers. If you're going to sell something, selling something to individual people at a neighborhood or a individual building or home scale, there's a lot more consumers that do that. And maybe instead of growing infrastructure, maybe we lessen demand by dealing with it in an incremental way. And I was curious what your guys' thoughts were on maybe that being the paradigm shift, that we're not relying on government infrastructure and more doing it on the local, smaller scale.
Who wants to grab that one first?
I'll give it a go. There's many ways of skinning a cat, and granted, we were, perhaps all three of us were focusing on the big picture and how can we minimize the discharge, how can we reduce the amount of polluting load, how do we cope with it, how do we make something better out of it. It's true, you can go upstream and you can implement different approaches to minimizing the discharge to improve the reuse of water at source. In some ways, the infancy of that idea came from the pre-treatment program. That drove industry to innovate and come up with different approaches to minimizing their discharge to the collection system, to recover water that they could reuse for whether it was just wash down purposes or whatever, which then took away from the need to use potable water. These are fairly simple concepts, and but they're not as widely implemented as they could be, and certainly that could be one of the arrows in the quiver that could be developed by the community. We don't necessarily have to focus on just one type of approach. So your point is well taken.
With that, I would still argue that there is a role for a centralized authority to or at least a coordinating authority, because what we do can have synergistic effects, right? So at least if we're aware of what we're doing, together, and generally that takes some sort of coordination, I think we can be a lot more effective.
Randy, any comments to that? Other questions? Right here in front, let's get a microphone to this gentleman here. Thanks, Bill.
Hi, my name is Michael Gottfried. I'm part of NK Architects. When you were talking about the education piece, I think one comment I wanted to make is, you know, in the past recession period, there's been a real opportunity to invest in infrastructure that hasn't happened in this country, I think, for various reasons. And I think one of the reasons is our ability to tell a story about infrastructure that's compelling and interesting. And I think that's what's happening up here today. A lot of times there's kind of a throwing facts at people and numbers, but there's a kind of compelling human story to tell about it. I mean, I'll just give one example is there's a great book that was written a couple years back called The Ghost Map about the water treatment system development in London in the 19th century, and it talked about, it was written almost like a mystery book, and it's compelling, but after you read that, you really understand why these systems came about. And I'm just wondering how, as a movement focusing on water and wastewater and so forth, how we can tell better stories that actually compel the public, because there's huge opportunities here and huge risks, you know, if we don't address these issues.
Telling the story, great question. How do we, you mentioned education. Part of that is the way you present the information, the way we all present it. So, Dan, thoughts on that?
Thanks for lighting me up first.
Well, Dan
and
Randy's next. Randy was going, no.
So, your point is really well taken, and the question is how do you make sewage compelling? And, or at least that's from my down in my weeds, right? So, and there's the human health side of this. And we've been beaten on that one for a lot of years. And for me, what seems to be standing out now is kind of what I think Henrik and I both touched on, is the opportunity here. Is that we're not working with a waste anymore, we're working with a resource, and how do we mine and refine this resource? And I think that's going to be the story that's going to fire people up. We've already done the human health thing, and I don't think we can beat that drum too much more and to much effect.
Randy or Henrik, either one.
I have, I'm blessed in the fact that I can target our community, Joint Base Lewis-McChord, a little easier than like the city of Tacoma.
You are the Singapore of Pierce County.
If they're inside the fence, I got them. That's right.
So we should refer to you as dear leader?
So, no. What that does, though, for us is that a lot of the people at Joint Base Lewis-McChord are transient, and that is they cycle through every 2, 3, 4, 5 years. What we have learned is as this cycling happens, our community is bringing new things to us from other places, either Europe or wherever they come from. And they really come from all over based on their assignments. We've also been able to harness those new ideas and incorporate them into our targeted information systems. And we use a variety of those things. And I can tell you, when you target your community with things that are relevant to them, you can really make a difference, and you can really get them on game day to go to work for you. And we see that with our sustainability program and how we're involving our community in our green procurement program and some of those initiatives. And we can actually see a difference in the way they buy things at the commissary and the PX as a direct result of our sustainability information campaigns. So it can work. But like I say, it's much, much easier for me because I'm dealing with something that's inside the fence. Now, having said that, I'll tell you that I also can make an impact in the surrounding communities because of the retirees and the dependents that are outside the gate that are now taking that education and that sustainability message and the conservation message that we deliver at JBLM to the forces outside. So it's about focus, it's about delivery, and then it's about creating the relationship of those two.
Henrik, last word on this one.
As you've probably noticed, I'm not from Tacoma. That gives me a different perspective, perhaps. One of the things that I've always been impressed about in coming to the United States is that the Americans have probably the most formidable marketing organization of anywhere in the world. They will persuade people to buy anything that they didn't even know they needed, that they didn't even think about that they needed, they didn't even know existed yesterday, and here they are buying hundreds of millions of dollars worth of that type of product. So in answer to the gentleman's question about how do we convince people to get more engaged, well, use the resources that we've got. Engage people who are gifted in that type of service provision. It doesn't take too much effort once you educate the marketer for them to come up with methods to convey to the public, to get them on board, to support these sorts of things. The other thing is you've got to educate the people who run the city, the mayor and the folks who are up at that level, because they're the people who are holding the purse strings, and they're the people who get voted in by the local folks here. So they need to be part of this machine too. You can't just leave it to the entrepreneurs to soldier on their own if they don't have very much support.
Thank you. Let's thank our panel one more time. Thank you.